you need to just forward to regarding the and MATLAB access. Okay. So yeah, I have not uploaded the previous video of the tutorial one. I will upload it maybe today or next day because I was busy in the last week, not in India right now. Okay. Okay, so if you have any problems in the previous like tutorial or assignment, have you done that? Have you done the assignment one? Hopefully you have done. Okay, so how many students are there? 20 students. Let's wait for 19. Let's wait for some few minutes more. Wait for some further more students. So have you seen the lectures after tutorial one? Okay, Sumit. So you have seen the lectures from lecture number 6 to 10, I think. Or this assignment 2 is based on lecture number 6 to 8. I see that it is based on lecture number 6 to 8. So we will discuss that first. And if we have time, then we will discuss the lecture queries, lecture related things. Okay, let's wait till 4 minutes more. Just 18. Okay, let me start now. It is more, not much time. Okay. Okay, so I should share my screen here. Can you see the screen? All right. Okay, so you all know this. Okay, I will explain some random questions regarding assignment 2. Just dummy questions here. So let's start from this question number 1. What is the 5-digit rounding value of the irrational number pi? So you know how to do rounding? Yes or no? You know that. So if you have a number like this, uh, 5.1126, and if I have to do the three up to 3-digit rounding, then how will I do it? Because you need to capture at least till 3 digits. So since 6 is greater than 5, so what it do is like it will increase 2 by 1. So what is the after 3-digit rounding, what is the number? It will be 5.113. Okay. But if it is lesser than 5, or maybe 6 is greater than equal to 5, then it, yeah. But if it is strictly less than 5, like this one, and this 4 is strictly less than 5, so what is after rounding to 3 decimal places is just 5.112. Okay. So it's just the basic stuff. So 5-digit rounding value of irrational number pi. What should be the answer of this? Anybody? So pi, you just write down as my marker is like this way. What is the value of pi up to 6 decimal places? Pi. Okay, so it is, let me use the calculator to find the value of the pi up to 6 decimal places. It is 3.141592653, maybe some more digits I write. So till 6 digits, 141592. So we have to retain first 5 digits after the decimal, right? Okay. So what should be the rounding value? Anybody? It's easy.
Option C.
3.141.
Yes, 3.14159 because 2 is less than 5. Maybe. So it's very easy answer. 3.14159. So it should be like this one. I just do these questions and I will explain this concept. Maybe this 8-bit and 64-bit, how to convert the numbers into the binary numbers, into random numbers. Okay. So a computer that represents 4 significant digits with rounding would calculate this as. So yeah, this is the same kind of question, but you just have to multiply these two numbers. So let's multiply them. What should be the after multiplication? What should be the number? Okay, let me use calculator. It is there. Okay, so it's 66.666 into 33.333. So after multiplying, so yeah, let me 66.666 into 33.333 is 222.2222.17778. Okay, so it's up to 5 decimal places, but we have to reduce the number till 4 significant digits with rounding. Okay, so it can represent only 4 significant digits. Okay, so after that, so yeah, what should be the number according to you? Anyone?
Option C.
Why?
D
Why C?
option. It's a
Why
D.
C and why D? Why C, why D?
Since
Option D is, yeah,
what is it?
okay, please go.
Okay, so yeah,
Before that,
yeah,
I
it's
think
not
after
saying about
decimal we
the
should talk about.
yeah, it's just saying about the 4 significant digits with rounding. It is not saying like in the previous question, in the first question. Let me go. Yeah, it's saying 5-digit rounding value. So it means correct up to 5 digit, correct up to 5 decimal places. It means that in the first question. But in this, it doesn't mean that. It means only 4 significant digits. So you just round the number up to 4 digits. It doesn't mean that up to 4 decimal places you just need to do rounding. It is saying that up to 4 digits you need to do rounding. So what should be the rounding value up to 4 digits? It's 2222. That's it. So it should be the answer D. Sumit, you want to say something?
no, thank you, sir.
Okay. So just understand in the lecture significant digits maybe or this difference. I'm not going to the lectures now. I will discuss lectures every lecture after this. Okay, so let's look at this question. Suppose P star approximate P with relative error at most 10 to the power minus 3. What is the largest interval in which P star must lies for the value of P equal to 150? So how many errors have you learned? Like, okay, so you have learned truncation error, I think absolute error, relative error, percentage error, these types of errors. But what is relative error? Let me write down this. So relative error is relative error. Okay, this is P star minus P, right, divided by P. Think, is this the correct definition? So is this relative error? Here it is saying that P star is approximating P. P is a number. P star is also a number. P star approximating P. So this is the approximate value. P star is approximated value. P is the actual value divided by the actual value, difference of two. Okay, so what the question is saying is that P star approximate P with relative error at most 10 to the power minus 3. So at most means it is less than equal to, is that it is less than equal to 10 to the power minus 3. And they have given the value of P to be 150 here. So what should be the right thing? P star minus 150 divided by 150 in less than equal to 10 to the power minus 3. Just multiply both sides by that way. So P star minus 150 is less than equal to 115 to 10 to the power minus 3 is 0.15. Okay, and here also. Okay, so it's not like this. Okay, so it will be P star minus 150 is less than equal to minus 0.15 less than equal to 0.15. So P star less than equal to 150.15, which is further less than equal to 1. What should be the right way? Okay. Yeah.
149.85.
Yeah. Okay. So this is it right? Is it 149.15 or 85? It is 85.
85. Yes, sir.
Okay. So it's easy. It is very easy question. A part is correct. Okay. So relative error, it may be absolute error or percentage error, like this question may be framed. Depends. But you need to be very careful about the definitions. If we perform 3-digit rounding arithmetic on this, what is the absolute error? The exact value determined to at least 5 digits. We perform 3-digit rounding arithmetic on this. So what is 3-digit rounding arithmetic? Anyone? So 133.921. Okay. Okay, what is the, if we perform 3-digit rounding arithmetic on this, what is the absolute error with exact value determined to at least 5 digits? What is this question is? Okay. I'm not sure how this is to at least 5 digits. Okay. Absolute error with exact value determined to at least 5 digits. Okay, maybe it's saying about the, okay, 3-digit rounding. But they have already rounded it. So in this question, maybe this is already done. So this is just rounding. And they are saying that at least 5 digits, we just go with that. Is there a mistake in this question? I think there is some mistake here. Okay, let's skip this one. Okay, this one, I just skip it. Okay, so what are the value of x and y while solving the following linear system using 4-digit rounding arithmetic? Okay, so you need to find the value of x and y, and after that you need to do 4-digit rounding. Okay, let's find. So in the first one, if you have, you just find like this way. 0y is 14.20. And this one, you just find the value of y in maybe x. Maybe you can find the value of x from here. So what is it? 14.0990y divided by 1.130. Okay. And this value of x you can substitute in the second equation. So it's 1.013 dx minus 6.099 y is equal to 14.2. So x is just this 1.013 divided by 1.130. X is just this 14.20 0y minus 6.099y is equal to 14.22. So what should be the, you just have to multiply this and divide by 1.130. Okay. Let's find the value of phi by this. Okay. So what is 1.013 divided by 1.130? 0.89646. 0.89646. So I'm using 4-digit. So you have to just take, because this computation, you may take more the number of decimal places, but I suggest you to take only up to 4-digit rounding. Okay, because the question says that you need 4-digit rounding arithmetic to do the calculations. So the exact value it will be, wait a second, just good. It should be 0.89. So exact value is will be 646. So if it is 46, just I take 5 because after rounding into 14.20 plus again this same thing 965 into 6.990y minus 6.099y is equal to 14.22. So you just multiply again this way, keeping 4-digit rounding. 20 into 0.8965. It's 12.7303. So it will be 12 point plus 0.8965 into 5 into 6.990. 6.2665. Minus 6.099 14.22. Easy. So we just subtract from 14.22 minus 12.7303. This is 1.4897 on right side. 1.4897, and on this side you have 6.2665 minus 6.099, 6.099, 0.1675, 1675 and y. So you just divide again. So 1.4897 divided by 0.1675, which is 8.89373. So after rounding, it should be 89.8937. Okay, so is it there? No, it's not here. What is this? And options may be problematic. Yeah. So y is 8.8937. So these three options doesn't match this. And please check with me if it's right, the calculations. And this x you can easily find by just substituting the value of phi, and keep at each step you need to make sure that you are using 4-digit rounding arithmetic. So maybe none of these, right? Okay. So this is easier. It's not an issue. What are the root of the following quadratic equation using 4-digit rounding arithmetic? So like this way, you can do like, what is the, this is the equation. And you have this implies, okay, the roots of the equation are. What are the roots of this equation? The roots of the equation are given by this formula minus 62.10 plus minus b square. 62.10 is square minus 4 divided by 2. Everyone comes late. Okay. So 62.10 square minus 4. What is this value? You need to keep the same thing again. 62.10 into 62.10, which is minus 4. 3852.41 is square root. The square root of 3852.41. But it is like, okay. 0, 0, 4-digit rounding. So it's just giving you 0. Just not fine. This one. So just do the square root of this number. It's the square root. Like 5, 6. Okay, let's do the square root. You also do the calculation with me. 3852.4100. Okay, let's do the square root of this. So it will be 62.06778. So after rounding, it should be 62.0678. 78 plus minus. So you just calculate these values and just calculate them. Okay, so 62 point minus 62.10 plus 62.067 minus 0 divided by 2 minus 0.0161. Is it there? Ah, it's not there. Okay, anyway. Minus 0.0161 and another value is if they say like you have to just round off to 2 decimal places, then you just need to do the calculation. Every step you need to do till 2 rounding decimal places, and maybe the answer will be minus 0.02. Not saying 4. So next thing is to find another root, which is minus 62.0678 divided by 2, which is minus 62.1039. So minus 62.1039, 4-digit rounding arithmetic. Oh, let me see once this one. Yeah, so it is 4-digit rounding arithmetic. So you can see that this should be the right thing. These should be the right values. So again, none of these should be the right thing here. So digit, not sure why they are not. Maybe in this question, maybe they can rephrase like this. It's not a right way to explain this question like this using 4-digit rounding arithmetic. So it's not the right. So you just write, you replace by this one, correct up to 4 decimal places after rounding. That is the right way. Again, the same thing. Yeah. So let's discuss the another question. So rounding, chopping. Chopping is just, you don't need to do rounding, you just chop off up to some terms that I will discuss when we will discuss the lectures after this. But first, these questions, random questions. Use 4-digit rounding arithmetic to evaluate this given fx. What is the relative error for the value obtained above using the actual value of f.1 to be this? So you have to use the 4-digit rounding arithmetic to evaluate f.1. So I just replace this question by this, or maybe the options will be used. Calculate the value maybe up to 4 decimal places after rounding. So what is the f.1? What is the value of f.1? Let's see. Approximated value. So it should be 0.1 into cos 0.1. Just write it here, equal to initially cos 0.1 minus sine 0.1 divided by 0.1 minus sine 0.1. Okay. So you just use the calculators to find the value of cos 0.1, sine 0.1, and this sine 0.1, and just use 4-digit rounding up to 4 decimal places, and then just substitute here. So what is the value of cos 0.1? Let's do this. Sine of 0.1. So it's like 0.99500. So you need to use 4-digit rounding up to 4-digit. Okay. So its approximate value will be 0.1 into 0.9950 minus sine 0.1, sine of 0.1. That will be 0.09983. So I just remove 3 over here, and this 0.1 minus sine 0.1. So again, this is the same value, 98. Okay, just do the multiplication. Okay, this is one calculator. 0.1 into 9.9950 minus 0.0998. Okay, so it is minus 0.0003. It's like that. Okay, I just use it. Okay, it's just approximation. Minus 0.0003 and 0.1 minus this 0.1 minus 0.0998, 0.0002. Okay, what should be the answer of this? 0.000. The right correct way to. Okay. So I think there is some difference. 0.3 divided by 0.0002. It's 1.5. So exact 1.5 minus 1.5000. All right. So just calculate the relative error. How do you calculate relative error? This is again the same. Relative error is just the actual value is minus 1.99899. Just use that whole, because you don't need to just chop off the actual value, or you just don't need to round off the actual value to 4 decimal places. The approximated value needs to be round off or chopped off. Okay. So just use this value as it is. So minus 1.998999, whatever. Okay, so P star is minus 1.5. This is negative, so just use plus 99 8984 times 98. 84 times 8 divided by this, again the same value. Okay, so what should be the answer? Let's see that. Wait a second. Okay. So minus 1.5 plus 1.99899998 divided by 1.99899998. So it should be 0.2496. So again, this is not here. I think 0.2496 should be the right answer. Maybe you can check if there is any calculations. 24962. So you just use it is just approximated value. Again, it's an approximated value, 0.2496. That's it. So there is some error in this calculation. You may be checking it once again. Maybe. Okay. So this way of finding this is easier, right? You can just do in every question like that. Okay, so what is the truncation error using left end point Riemann approximation method with equally portioned points? Okay. So, okay. So how to find the truncation error in between them? Is it the absolute error just like that or anything else? Where we use truncation error? Anyone? Truncation error where we use? Like in the sin x series approximations, we use truncation error. We used to chop up to some places, and then that the remaining terms contributes to the error. But here it just means absolute error, right? Is it fine? So just calculate the actual value of this integration, compare with the Riemann approximation method with equally partition points in this way. So what is the Riemann sum formula? Anyone? So -3 to 9x cube. Cube dx is just approximated by Riemann sum. So it is a left-hand point Riemann sum. So the value of f is like this. Summation is approximated by how many points are there? -3036. We don't need to check the right-hand point because it's just left-hand point. And what is the value of the space? The spatial step value. What is that? It's just 3 because it's just adding 3 over there. Okay, so how many points are there? There are 4 points. I equal to 1 to 4. Fxi del x. Del x is just same. So what are xi's? X1 is -3, x2 is 0, x3 is 3, x4 is 6. Is it fine? Yes. So just substitute these values in it. Okay, good. Not. Okay, so f of -3. So this integration is approximated by this f of -3 into 3 plus f of 0 into 3 plus f of 3 into 3 plus f of 6 into 3. Okay, so what is f of -3? Just cube, make them cube. -27 into 3 plus 0 plus 27 into 3 plus 6 cubed, 216 into 3. Just add them and Okay, so what should be the answer? Let's see.
648.
Yes, yes. You were saying
648.
648. Okay. Is it fine? Okay. Maybe you're right. And what is the value of? No, I'm not asking the answer of the question. It's the truncation error. Okay. So you are just telling the correct answer after this? Maybe notice the so that. Have to find the absolute error. We will calculate the actual integral value also. Let's wait for it. So minus 27 into 3 plus 27 into 3, that is 0, and 216 into 3. Okay, you are right. Yes, you are right. Sorry. You are just right. Okay, so what is the actual value? You just tell me also this thing. What is this actual value? It's it minus, okay, just this minus 3 to 9. What is this actual value? 9 to the power 4. Is 7 to 9. Okay, into 9. 6561.
One six two zero.
1620. So what should be the absolute error? This is the actual value. One six two zero.
972.
Is it there? Yeah. So 1620 minus 648. Okay. So absolute. In this case, truncation is just same as absolute. It's 972. That is correct. Okay. It's just easier. It's just easy question. Okay, so here lat fx is again the same question, but here they have twisted something like you need to find the value don't using by not using the calculators and correct up to 4 decimal places, but you just need to use the Taylor expansion. Okay. Taylor polynomial expansion. Do you know the Taylor expansion of cos x sin x? How
Yes,
do
sir.
you okay, tell me. What how do you
Then
approximate cos x? Is
cos
approximated
x can
as
be approximated as 1 minus x square upon 2 factorial plus x to the power 4 upon 4 factorial, like that.
it is minus x to the power 6y. Is it like same like this?
Yes, sir. So
It's true. Okay. And what about sin x? Anyone?
x minus x cube upon 3 factorial plus x to the power 5 upon 5 factorial.
Okay. So it's just the integration of previous. Say 7 factorial. Okay. But the question doesn't say, so we have to specify something in the question that up to which term I have to retain up to what terms of the Taylor series Taylor polynomial. So I just retain, this should be mentioned in the question, but I just retain up to this part, up to this part, up to 3 terms. Okay. So you just need to find out the value of the, okay, maybe for our simplicity, we can just use these 2 terms for calculation. This one. Okay, so 1 minus x squared by 2. You just use this term in, you just replace f of x by substituting the value of this and this in the definition of f. So what should be that? What should be our new fx value? X into 1 minus x squared by 2 minus sine x. So minus x minus x cubed by 3 factorial. Okay. And x, so just write 6. And this one is just x minus sine x. So it is just x minus, okay, let's choose x minus x cubed by 6. Okay, so what should be the value? Should be x minus x cubed by 2 minus x plus x cubed by 6. So just cancel this x over here. And x minus x cubed by 6 is just x cubed by 6. Okay, so what should be the value now? Because x is 0.1, so we just cancel out x cube over both. So x is, if x is positive, just minus 1 by 2 plus 1 by 6 by 1 by 6. What should be the value of this one? Just calculate and down.
-2.
What should be
-2.
that? Are you sure?
-2. Yes, sir.
-2. Okay, I believe you. So it's up to you have already rounded it up to 4 decimal places. Okay, it's not saying anything about it. Okay, maybe it's not. That's why it is like this. Is it exactly -2?
Yes, sir.
Okay, fine. Because we have just written 2 terms and can retain more terms. Anyway, the answer may change because it's not specifying up to how many terms we have to retain in it. So just find the relative error and tell me what is the relative error. Okay, just do that calculation. Like in the previous one, you just need to use the actual value of f, just 0.1, which is minus 1 point, this one, you just use it. And what should be the formula for relative error? Okay, maybe I just see it is f star. Why people come late? So f star minus f modulus divided by f. What should be its value? Just tell the end. That's it. Okay. What is this value? Can we discuss the lecture part somehow? I will discuss in the next hour the lecture queries. Or I just start from the 6th lecture. We sir discuss something. Have you found out? Have you found out this value?
Sir, can you please show the actual value of f?
Okay, maybe. Oops.
Sir, it's approximately the first option 0.00050.
Is it right?
Yes, sir. I am getting 0.00.
Okay, okay. Okay, maybe I believe you. So 0.00050 up to 5 decimal places you are calculating, is it? Or just you are getting exactly this value?
No, sir. I am calculating up to 5 digits.
Okay, okay. It's fine. So I believe you 0.00050 maybe. But yeah. It's not about the values, how you calculate, but you should understand the language and concept and the question behind it. Okay, like this. So it's just the basic. So in the previous lectures, you have seen the MATLAB based things, and here,
Excuse me, sir.
yes, yes.
Sir, can you please explain why we are taking up to only the power of 2, that is x square by
Okay.
2? Why we are not taking the further powers?
Yeah, it can be, but it should be specified in the question. Here it is not specified. I just specified up to 3 terms. Okay.
Yes, sir. Thank you,
It
sir.
should be specified in your question up to how many digits, up to how many terms you have to take. Or it should specify the order of the truncation error, right? It depends on how it is specifying. Okay. So if you permit, I can discuss the lectures. Or maybe I discuss the assignment. Have you done the assignment problems? This assignment problems next week. Has it been uploaded? Wait a sec. I just. Okay, maybe I just discuss the lecture concepts now because they will be helpful to maybe some of you may have not seen the lectures properly. I just see. So let's discuss them. So okay, just open the lecture number 6, okay? In your lecture note series, just open that. I have already opened, I think this one. I just show. Can you see my screen? Here is lecture number 7. Okay, I just changed it. So here sir has introduced you the errors in the computation. Have you seen this lecture? Okay. So round of error and truncation error. What is the difference? What is round of error that I've already discussed with you? Let us see truncation error, maybe what he wants to discuss here. Okay, so here you can clearly see that. Yeah, just okay, here you would just see that he's trying to approximate 1/3 and yeah, so up to 5 decimal places and just take the difference, maybe absolute difference, and you just try to calculate this value. And the question may ask you like, what is the round of error correct up to 5 decimal places or 8 decimal places or 10 decimal places, depends on the question. And just you calculate with the actual value and with the round of up to 5 decimal places you have done. So just find the error in that way. So this error value is going to be continued, but you need to just round it off up to some decimal places as specified in your question, maybe. Okay. And what is truncation error? How do you define it? Okay, so like in this one, maybe. So yeah, so truncation error is just different, like e to the power x. You have a series expansion of e to the power x. You just write it to, okay, I just show here. Like in this way, you are having cosine x expansion, series expansion, but you know the actual value of cosine of some at particular point. You know that. So you just have to calculate the difference between the actual value and the approximate up to, because you are taking up to 2 decimal places. Just calculate the difference between them, and that will be your truncation error. Up to how many digits you can retain. That may depend it. Truncation error may change. Truncation error may change depending on the number of digits you are retaining. Okay. Okay. So it's just about the series things. This truncation error is just about the series things. I think here he discussed about the integration. I think we have discussed this thing, that truncation error in integration, Riemann sum. You just calculate the integral with Riemann sum. It's kind of a approximation and compare with the actual value. That's it. Yeah, the most important thing that I want to discuss with you is binary form, a integer representation of a number converted to a binary form. Okay, that computer used to store these values over there. Okay, so let's discuss them. So we used to discuss 23 in binary form, how he tries to uh, convert this number 23 into the binary form. You know how to convert a number into binary form?
Yes, sir.
Okay, have you seen the lectures? Every lecture?
No, sir.
Okay, you have not seen. So maybe I just recall if it's fine. That,
Yes, sir.
okay. Okay. So let us see here. I just go with that. Okay, positive integer conversion to binary forms. Okay, wait a second. Yeah, so how do you convert a number like? Okay, so let's see this number 23 itself. Okay. So you just start with, okay, so how do you convert 23 into binary form? So you have to take 2, start from 2, just divide 23 by 2. So what should be the answer? And just write here as remainder. Or I may start with some other number later, but with the source number. So 2 ones are 2, 2 ones are 2. So the remainder is 1 after dividing 23 by 2. Okay. And you have to divide 11 by 2. So what should be the answer? 2 5 to 10 and 1. Again 2 2 to 4 and 1. Again 2 1 to 2 and 1. 2 and it is 0. And it is 2 zeros. So 0 and that should be 1. Okay. So you have to make here 0. And you just stop after a while. So what is the binary representation now? Can anyone tell me if you have seen the lectures? What should be the binary representation number and how to recover it? So it's just 10111. 2 is used for binary because binary means only 2 numbers, 2, 0 and 1. Just writing this number in 2 numbers. 23 is converted to just 2 numbers, 0 and 1. Okay, how do you recover this number? Anyone? I want to recover back.
Sir, we just multiply 1 and
This,
power of 2.
okay, it's wrong. We just multiply by 1. Which power do you mean?
Sir, unit digit multiplied by 2 to the power 0. Next digit 2 to the power 1, like that.
Okay, okay. So let's start multiplying by this way. Okay, so this digit you are saying that we should multiply by 2 to the power 0. This one?
Yes, sir.
Okay, I just start with the previous. The number is constructed in that way. Okay. Okay, so how many digits are there? Total 5 digits. So you need to multiply by if you're multiplying last digit by 2 to the power 0, then you just have to multiply the first digit by 2 to the power 4. Or 4 into
Yes, sir.
1 plus 2 to the power 3 into 0 plus 2 to the power 2 into 1 plus 2 to the power 1 into 1 plus 2 to the power 0 into 1. I think it should be 23 if I'm right. Okay, so what about this number 59? How do we do that? How do we do the binary representation of this number? Should we start from 2? What do you say?
So divide and do.
By 2? So 2 to the power 2 to the 4, 2 9 to 18. Okay. So what should be the remainder? 1. Again, 2 to the remainder 2, 2, 4 to 8. What should be the remainder? 1. 2 7 to 14. What should be the remainder? 0. 2 3 to 6. What should be the remainder? 1. 2 1 to 2. What should be the remainder? 1. 2 0 to 0. What should be the remainder? 1. Okay. So is this fine? What should be the number now? 1 1 1 0 1 1 2. Just check whether it is fine or not. You just try to recover the number from this. So how many digits are there? 3, 4, 5. There are 5 digits. Earlier there were also 5 digits, but depending on the 2 to the powers, you have to multiply. Yes, yes.
Yes,
What
sir,
you are
it is
saying?
correct.
It is correct, right? So like this, can you do with any number in positive number? I'm just talking about the positive natural numbers. No, natural numbers are positive anyway. So it's all about them. Okay, we try to see some other things. Okay. Wait a second. Okay, so how do we store a number in an 8-bit computer system? How do we store it? I think he's trying to say like this. It is storing. So this example, I used a number in 8-bit computer. Okay, so how do we do that? So just make the 8 digits. Okay, anyone knows how to store this number? Like I have to store this 59. How do I store it in an 8-bit computer system? Anybody? What is the correct way to do that? Okay. Okay. What is the correct way to do this? What is the first column represents? It represents the sign. Okay. So like 59 has sign positive. So I just take as 0. If it is sign is negative, then I just take as -1. Oh, okay. Sorry. It should be 1. If it is positive, just take sign to be 0. And if it's negative, just fill the sign column with 1. But plus 59 is just plus 59. It is just plus 59. It is so its sign is positive. So just fill it with what y0. Okay. Now this is the binary representation of 59. Okay. Just use this. So just start from the last point. So 1 1 0 1 1 1. So it should be 1 1 0 1 1 1 and fill it by 0. Anyway, remaining terms. Okay. So is it right? Is it right way to represent a number in 8-bit digit computer system? Anyone? Have you seen the lectures? All right. Okay, so you just multiply by 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, and see this just sum it. And what should be the number? It should be 59. It is fine for you. Okay, so like you can see in the lectures that the integer value range in 8-bit computer system lies from 2 to the power 7 minus 1 to minus 2 to the power, minus 2 to the power 7 to 2 to the power 7 minus 1. So you just see that, okay? See the lectures. And how do you store the number in a 64-bit computer system? How do you do that? So it's just like the same, but only you have 50. Okay, maybe I'll just go back once. Okay. You just try to look at how to represent the number in a 64-bit. Okay. 64 or 16 bits computer system. You just try that. I'm just going with the floating point representation of a number. Okay. Okay, so how do you represent the floating point how do you represent a floating point number? Let's see. Let's see the third example. I just made okay. So sorry, it's showing like if this is 0.75, I'm just recalling everything. It is 0.75 number and it is in normal number like you used to see. But you need to convert into some binary form representation. Then how do you do that? So just multiply the number again and again by 2, 1.50. Okay. And just retain this last digits beside the decimal digits. This is 50.50. So just multiply 0.50 again by 2. What is this? 1.00. And after that, yes. So this number 0.11. Just retain these things after that. And this is the decimal representation in the binary case. All right, like you do with any type of number you can. So it's just that. And how do you recover the number? Anyone? How do you recover this 0.75 from this one? How do you do that? 0.11. So to do that, you just need to follow the same procedure. Okay. So it's just 0.11 to 0.75. I just write normally. So how do you do that? 2 to the power minus 1 plus 2 to the power minus 2 into 1, of course. Just multiply this term, and just sum it. So what is this? 4, which is 1 by 0.5 plus 1 by 4, which is 0.75. Is it fine? So recovered. This number is recovered. Okay. How do you do with 0.4? What is the decimal representation? What is the binary representation of 0.4? Anyone? What is the procedure? Or maybe I just write another number. 0.8. What is the binary representation of 0.8? So 0.8, you should multiply it by 2. Let's see. 0.8 into 2 is 1.6. Just retain 0.6 into 2, which is 1.2. Just retain 0.2 into 2 is 0.4. Just retain 0.4 into, my God, 0.6 into 2 is 1.2. 0.2 into 2 is 0.4. So now how do we proceed? Okay, so it's like 0.4 and yeah, 0.4 into 2 is 0.8 and yes, I mean 0.8 into 2 is 1.6. Again, you just 2.6. So it's like a repetition. You can see that. What is this? Like repeating. This number starts to repeat. This number starts to repeat after that. What is this like? So it's just a repetition of the in the binary numbers. Repetition may occur up to this is like a loop. Okay. So what is the correct number now? Anybody? What is the binary representation of this number? 0.8. Tell me.
0.
Yes.
0.1100 whole bar.
Wait a second. Okay. 0. Let me write 0011, right? Or something different. Is it that? Is it right or not?
It should be 100.
You are saying 1100. How do you recover it? Okay, let's try to recover. Maybe see if it's right or not. So 2 to the power minus 1 plus 2 to the power minus 1. Okay, so it's not the way to recover it. 1 by 2 plus 1 by 2 plus 1 by 2 plus 1 by 2. It's not the way. It's not. Okay, it's not that. Let me see this one. I'm not sure. What should be the number of this one? So how do you recover this number? Do you know that? Wait a second.
Sir, no, sir.
Yes.
No, sir. I don't know.
Let me see. Wait a second. I just checking. Okay, I just check from the lectures. Okay. To the power 2 and 2 to the power 1 and 2 to the power 2. 1 to the 0.75 it is. I have to see this number. How do we recover it? Maybe in next lecture I will show you, but you just try to see. But it should be the right way to represent it. Yeah, it should not be the right way, I think. It should be the right way. 11001100. Is it? It should be the right way. Just try to check it. So the question I left you, like, how do I recover this number? The number. I will ask it in the next class. Maybe on mail I will reply that. How do I recover the number from binary representation like this? Okay, that's all. Okay. Okay, so if I have a number like in different fashion, maybe 1.5 something. So do you know how to find the decimal, this one? Binary representation of this type of number? 1.5. Anyone? So sir has introduced you a concept like if you can convert a number like this way, I'm just recalling this x to be. Okay, let me write it. X to be plus minus s into d to the power e. So what is s here? Yes, s. What is s? Just significant digits, okay? And what is e? Exponential exponent. And d is the decimal point. So how do you write like a number like this? So if 1.5, how can I write like this? 15. Okay, I just write 0.15 into, what should I write? 10 to the power 1. Okay, so this number can be written in this way. And we know the binary representation of 0.15, right? Is it? Okay. So let's see if there is some hint over there. And you should look at this thing normalized in scientific form, okay, yourself. I think you have seen this one. So this number is converted into normalized form because I just know the decimal binary expansion of this type of number. So it is like a normalized form because s is between 0.1 and 0.1. Okay, this is s. This is between 0.1 and 1. So it is converted in the binary representation point form. Oh, and sorry, normalized form. Just look at them. Okay. So now we just try to find out the decimal representations of these type of numbers here. Floating point representation of these types of number. Wait a second. So if you have wait a second. 210 floating point of the form 0.011 minus 1. Okay, yeah. So I have this number, suppose minus 1.101. If I have this number, then you just convert it in this form minus 0.1101 into 10 into, okay, it's just like 10 to the power 1 into 10 to the power 1. And what is the floating point representation of this number? Okay, so we form floating point form and this number. Okay, 10 to the power 1. So 10 you can divide, multiply by, because 10 is the binary representation of 2, is it? Yes, 10 is the binary representation of 2. You just replace them. This number 1 is just 1. So 10 you just replace by 2 to the power 1 if you want floating point representations. Floating point. And you just convert this number into the number I've just told you. How do you come recover that number? That would be the floating point number. But the main idea is like this. If you have 1.111.1, then you just try to find out the floating point representation of number. So 0.1111 into 10 to the power 3. Okay. So this tan, okay, wait a second. Okay, so how do you compute? Right, 3, yeah. So in the binary form, what is the number? 1.111.1. So this is the binary representation, okay? And this is also the binary representation. This is not the binary representation, so just convert it. So what should be that? How is 3 written in binary form? 10 to the power 2, which is, okay, sorry, it is 11. Why? Because you just do with 3. What is 3? 2, 1, 1, okay? 2, 0, 0. Okay, maybe I just write 1, yeah. So it should be 1. Okay, so 1, 1 is the binary representation of 3. You just replace by that. That's it. All right. Like this, you can convert any type of number. Keep in mind. And if you have to store this number, these type of decimal numbers in the 8-bit computer, just not that, this thing. Five, six, seven, 8. Okay. This sign, this represents sign again. This represents this type of thing. 2, 3, 4, 5, Mantissa. Mantissa. And this represents the sign of exponent. Okay, 1, 2. How many points I've taken for Mantissa? 1, 2, 3, 4. Okay, sorry, here. This is representing Mantissa and this is the sign of exponent. So how do you represent a number in this way? Okay. So 1, 1, 1, 0, 1, 0, 1, 1, 1. So if I have a number like this one, 0.1111, how do I represent it? Into 10 to the power 11. What is the sign of, what is exponent? It is 0, 1, 1, right? So just write 0, 1, 1. It is positive, so just write 0. It is 0.1111. So just write 1, 1, 1, 1. Okay. So that is the test. That is the 8-bit exponential representation. Okay. But for the repeated things, you just have to look it. Maybe. For 64-bit, you just try yourself. And significant digits I've already discussed. Okay. Rounding, how many ways of just okay. So if you are given a number, you just do rounding and chopping. You know what is rounding and chopping? You know that. The time of chopping of a number, I just know. Errors. What about the errors? I have not discussed this. I think lecture number 8. I'm into lecture number 8 now. So what errors sir has discussed with you? Can you name them? And which error you feel is good? Just name them. What errors sir has discussed with you? How many errors? Absolute error, percentage error, and relative error, okay? Absolute error, percentage error, and relative error. And you have just, okay. What are the arithmetic operations on errors? Okay, next thing is arithmetic operations. Anybody knows how to add 2 errors? Yes. Star x2 star x3 star x1. Just errors can be added simply like the way you add numbers. That's it. Subtraction also can be done in that way. multiplication. Okay. Division of the errors, you just look at them. I'm not going, these are all in the lectures. I'm not going into them. I will discuss some other things maybe for future lectures. I will discuss assignment problems maybe. Okay. Question number 9. Just look at loss of significant digits in the lecture number 9. He will explain you how to avoid the mistakes while calculating the number of significant digits. And yes, for sure. Okay, let me see once what I can. Then there are some methods after that which are used. Okay, iterative methods, and iterative methods will be the next lecture, and I think there will be questions on that. I'm going into the assignment problems now. Let's wait. Okay, assignment number 2. What is that? Assignment 3, assignment 2. Where is assignment 2? 3, 1. Next. Get it. Don't have assignment 2 solutions. Okay, I have. So how do you write the, let's open assignment 2 and just look at this question. How do you write this number in the decimal representation? Okay, in normalized form. The first question is the normalized form. How do you write this in normalized form? Okay. How do you write it? Anybody? Anyone? How do you write this number in normalized form? This is the first question of your assignment 2. Have you done the assignment? Yes, this SAT. Tell me. Think you have not done the assignment 2. Okay, just use the similar procedure. You just try to convert in this way. Use 4 digits, significant digits, and use 4 significant digits. This is the hint for this question. Okay, I'm not going to do this. You just use how to learn how to write a number in normalized form. Okay. Anyway, now next question is this number 75.8125. So how do you convert this number in binary form? Everyone knows now? The way I've shown to you like that. Just look at that again. This is all in the lectures. Third question is about the how do you convert this number 2.718281828 this number into after rounding into 5 decimal places, what should be the answer? That is very easy question. This is not a big deal. Just look at this. And fourth question is just again the same type of question that we have discussed, 541.55. Okay, let us do. into 4.33. You just multiply this number and chopped off or round off. Fifth question is about the okay, so you have to multiply a number by 10 to the power 7 minus something over there. Okay, I'm not sure about fifth question. I just remove it. Sixth question is about the this one, x square minus 90x plus 1 is equal to 0. And you need to calculate the roots of this equation. Correct up to some. So what is the question 6? Can anybody read it? I don't have any questions. Anyone? So like the similar way that I've shown in the previous thing. I'm just going with that. Okay, maybe I just show there. Here we have done this type of question, I think. Is it similar to that? Seventh question? I think it is very similar to it. So it's fine, you can. Okay. Now the seventh number question. What does it says? Seventh number question. What does it say? You are given a function of, I think, exponential function you are given, and you need to find out the maximum bound on the truncation error. Okay, so how do you find it? You just try to calculate it. Okay, so you just need to find out the, so e to the power x is approximated as 1 plus x squared by 2. Okay, it is equal to plus, there is order of x cube. So it is e to the power psi maybe, or u psi cube by point. I just write remaining order of error. This is truncation error. And you need to find the bound on this truncation error on the interval. The truncation error is just this. Truncation error is just this one. And you need to find bound on this truncation error. Bound on the truncation error. On the interval. Xi varying between 0 and 1. Okay. So can you find the bound on it? Is it easy? It's a very easy question. You can do that. Next question is again same type of question it is. So you are given a function f of x, which is say x sine x plus 2x. And you are given a function, you have to find the approximate value of x. So like the way I've calculated, maybe they have asked you in the question to find out the value of sine at 0.2. I think at x is equal to 0.2, you are having the values. So just calculate f approximate minus f exact. That's it. And just calculate the absolute sum. So what type of error it is? It is absolute error. This is very basic. So you just calculate the f approx at 0.2 and f exact at 0.2. Okay, this is easy question. You can do that. But you need to, this is specified in the question that you need to use the calculator or you need to use the Taylor series approximation up to some digits. That's it. Okay, so what is the ninth question is about the loss of significant digits. How do you identify the loss of significant digits? It's all about the ways the sir has mentioned in the lecture. You can just try to see that. Okay, so and you try to find out the correct option out of them. That will help you. Yes. And the 10th question is about the, what is this? I think again it is about the rounding. 9th is done. 10th is about the rounding. Decimal places. Now, let me know if you have any questions. Yes. Yes, if you have any questions, just ask me. Feel free to ask. Have you done the assignment too? No, I think no one has done. Maybe. Is it recording? Okay, I just stop sharing the screen and let's wait if you have any questions. Okay. I've just recalled. Okay. Yeah, what I've done today is just I have done some random questions and about the concept based. And next thing I've done recalling the lectures of what comprise my like I have recalled the lectures which are the part of today's tutorial. And at the next point, I have done this assignment problems that are given to you. Means I have not done, but I've just given you the idea of how to solve them. So maybe you can record, this is already recorded lecture and you can always see that later at some point of time. But yeah, if you have any questions, feel free to ask. I'm here for some more minutes. Because this has to be ended in 2 hours. So yeah. So it's so many times. If you have any general questions, you can also ask them.
Hello. Sir, I'm Sharav. Am I audible?
Hi, Saravan. Are you
Yeah,
there?
actually,
Okay.
yeah, I
Yeah.
just joined a bit late for this course, maybe just 2 days before.
Okay.
Probably that week assignment I'm just classes I'm going through. I understand like we have 2 more days to submit, maybe till 7th on the first session. Probably this whatever now I have gone through, probably I can have a video link of it. I have seen that there is a linkable video link is getting uploaded
Yes,
in
I
some
will
kind of
upload it.
extension.
This, yeah, the
Yeah,
video link is not available last video. Yeah,
yeah,
for the
yeah. Because
initial
I'm
1 hour, I forgot to start the recording, but for the next 1 hour, it is available. It will be available soon.
fine,
Actually,
fine,
I
fine.
have to. I'm outside India right now. I just have to travel in the last week, so I don't.
Fine,
I
fine,
just
fine.
don't
Sorry.
have time
But
to.
anyway, now that because actually for me also it was like 2 days before only I joined, so I could not hear your first session of it.
Okay,
So anyway,
you are
since it
not
is
able
already
to understand today's session.
no, it should
Are you
not.
not?
I could. It's basics only, but still it
Okay,
will be
it's
like
just
easy.
basics.
Yeah, yeah. It's very basic, but just if the video link is there, we can brush it up. That's why.
Hmm. Yeah, I will. I will upload the notes, videos, everything.
Thank you. Thank you. Thank you.
And one thing also, is the link of the video available here? Can you check it in the MS Teams link server? You
Just
can also,
let me. It is posted in this chat box or
yeah, you just check it if it is available to, you can just see that from there. If it is. For now, I will upload it, but yeah.
yeah. Actually, I could not see that link since it is recorded. Probably it should be available, but I could not see that link.
Okay, you have not seen. Okay. Okay, I will upload it.
Yeah, I'm able to see that link. Yeah.
Okay, just see. Anyone has any questions? So this MATLAB tutorials are done actually, and you don't need to use MATLAB, I think. So in the in the future assignments, future tutorials, but you can itself practice it. That's it.
Just one more
Yes, yes.
just one more clarification. Actually, that's for examination, do we have permission to use calculator like for the numerical business? Or,
Yes. It will
oh, and it will
calculate
be
your
MCQ. It will be MCQ type, right?
Yes, it will be
Multiple.
MCQs. Yeah.
Thank you.
Is it your
Thank
first time attending NPTEL course?
Yeah, yeah. Actually, for my PhD coursework, I am trying to like this course to be completed. And basically, it is with chemistry. I'm doing in chemistry background, but maths and RM are compulsory.
Okay, okay.
This is the first time
In which university you are?
currently with Indian Institute of Space Science and Technology, IIST. With, ISRO.
Okay, okay.
Thank you.
Time it is like, okay. I'll just wait for 10 more minutes.
Can we have two live sessions like 1 and 2 something, because it is clashing with some other classes also. It's very difficult to manage.
Okay.
It's better to
Okay.
attend live than other than attending recorded one. So that's why I'm requesting if you could do 2 sessions so that we can manage with the classes.
So you are saying 1 hour sessions of two
No,
sessions?
like different time, different date or time, 2 sessions, like maybe on Saturday 3 to 5 or Sunday 3 to 5, something like that. Because we got a mail and almost all the live sessions are on Saturday 3 to 5, 3-4
Okay.
courses. So
So
that
you
is
are
the
saying me to change the timings of the lecture.
timing, or we can have 2 different time sessions, like whatever is comfortable.
Yeah, then it's not in my hand actually. These all things
Actually, I
are in.
mailed NPTL, but
Okay.
I did not receive any reply from them.
Yeah, the
I
NPTL
told.
NPTL has a policy that I can take only a 2 hour session in a week.
Actually, last week we had this option, like session 1, particular timing, and session 2 another particular date at another particular 2-hour timing. So it was very easy to attend the classes. This
Okay.
time I got mail that 3 of my classes are on
Mm,
same time, so it is
mm,
really tough. Like for
yeah.
one day it's fine, but
So
if
you are
I have
attending 3 courses at the
no,
same
I'm
time?
attending currently 4 courses.
Oh, okay. Oh, yeah. It's quite hectic. You can see the recorded lectures, okay?
Yeah, okay, fine. Just a request if
Just email
possible.
me. I have sent my email, yes, in the
Yeah,
last
I got
lecture.
it last time. Yeah.
You can
Okay.
just email me if I just, because there is a lot of time, I just want to have some queries and I just want to answer them. In the next lecture, maybe I will answer.
Okay. Okay. Thank you.
Yeah.
Sir, excuse me, sir.
Yes.
Sir, during the registration for the exam of this course, we are not getting the option for Department of Mathematics. What shall we do?
You just write to NPTEL support. I can't help you.
Okay, sir. Thank
In
you.
the chat box, you can see the email ID. Okay. Just practice for the exams. For the exams, practice is very important. You need to practice on the calculators, on maybe on computer-based calculators. It will be very helpful, right? Because it takes time to do the lengthy computations. The exam may be lengthy. It depends on the, because these are just basic things and it doesn't take time till this lecture, till this tutorial, but more upcoming tutorials, in upcoming tutorials it may be lengthy, the lengthiness may increase further, and so you need to practice more and more to just finish that. So there will be 50 questions right in the exam, you know that. And I think some are some are assignment based problems, some are recall based problems, some are open may be some tricky, but these can be done. Recall problems are very few. Recall problems are very less. Assignment problems are little high, and yeah, open problems are higher. I think 20 to 25 questions are open out of 50, and rest are based on assignments and recall. Assignments and recall based questions are easy to do, I think. But yeah, you need to do practice of them.
Excuse me, sir. Can we take
Yes,
scientific calculators to the exam?
I think these are permitted. Yeah. Just
Thank you.
for your confirmation, you may ask support, but I think it's permitted. Yeah.
Okay, sir. Thank you.
Okay. Let's close it. It's a code. Just search. Yeah, just stop now. Okay, bye.
Thank you. Bye.